Hello, everybody. We've been talking about exponential change, and what we've been talking about is specifically exponential decay, where you have less and less as time goes on. And I just wanted to really clarify something we've been talking about, which is how you find the multiplier or sometimes called the factor, given the information in a word problem. And so this is the sort of situation that we've seen a couple times. Um, Maybe you have a situation like a car uh, is worth, let's say it's worth 20,000 when it was bought, and loses. Let's make up a fraction. Let's say it loses 1/4 of its value each year. And so what that means is that every year we have to figure out a quarter of what it is worth in that particular year. So we can actually start just by looking at some numbers as examples and then come up with an equation, because it becomes annoying to just keep calculating out examples and examples and examples. So let's make a table here where I'm saying here are the years and then here is the value of the car. Please remember that we start at year 0. That means 0 years after I purchased the car. The moment I purchased the car is year 0, 20,000. So I can do 20 or I can do 20,000. Then after 1 year, it lost a quarter of $20,000. So you can grab a calculator and just type in 20,000 times 1/4. So you see, all I did was I know my calculator is a little weird, but I just did 20,000 times 1 divided by 4. 1/4 is the same as 1 divided by 4. And so it loses $5,000. And so that means I can go 20,000 minus $5,000 and get 15,000 just like that. Okay? So I'll write out also just the process so you can see what we did. We did 20,000 times 1/4. That's 5,000. And then we did 20,000 minus 5,000, and that's 15,000. We can do that same exact process again. Now our car is worth 15,000. So we go times a quarter. What does that give us? 15,000 times 1/4. Looks like that's 3750. And then 15,000 minus 3750. Looks like that's 11,250. So 3750. Then we do 15,000 minus 3750, and we get 11,250. So that's the value of the car after 2 years. So what I'm going to do is I'm going to type those points in to this graph here. So 0 and 20,000, 1 and 15,000, oops, there, and 2 and 11,250. And I'm going to zoom it out so that we can see those values. Let's make our y-axis go up to 25,000. Okay, there we go. And now we can see those 3 dots right there. We can see the y-intercept, and we can see the 15,000 and the 2 and 11,250. I hope you can see how this becomes a real pain in the butt if you have to keep going and keep going and keep going. So one way to answer this in a more efficient way is to turn the fraction on its head. And what I mean is, we were thinking of losing a quarter and then subtracting that from the total. Well, if you have a total, the total fraction is represented just by the number 1. That right there represents the total. And you lose 1/4, so I subtract it. So this is lose 1/4. And if you do one whole thing minus 1/4, you have 3/4 remaining. You always can look at the denominator here, and that tells you what you're subtracting the numerator from. So 4 minus 1 is why I have 3/4 left over. And it turns out that the numbers that I just showed you can be got more easily if you just go 20,000 times 3/4. And you can see 20,000 times 3/4 is 15,000. And 15,000 times 3/4, oops, is 11,250. And now this is just a one-step process rather than like I was doing here where I multiplied by a quarter for step 1 and then subtracted it for step 2. I can actually simplify that. I can shorten that and just say it's multiplying by 3/4 for year 1. And for year 2, it's multiplying by 3/4 again. And for year 3, I would just multiply by 3/4 again. And so that gives us the key idea that we can actually shortcut this process by just multiplying by 3/4 for every year that we own the car. Well, we know how to show that you're multiplying by something over and over again. The way you show that you're multiplying by something over and over again is to use an exponent. So the shortcut here is that the value of the car starts at 20,000. So I type y equals 20,000, and you can see now my purple graph hits it right at the starting value. But then it gets 3/4 as valuable. Now you can see that it's hitting it for 1 year because I multiplied by 3/4 once. And if I raise it to the x value, then I hit all of the values. Because when you raise something to the x value, you're telling the computer multiply by 3/4 as many times as the x value. So multiply by it once for year number 1 right here. Multiply by it twice for year number 2. And you can use this graph, if you click and drag on it, you can see what the value of the car is at any point. And it turns out the car is never worth nothing because there's always 3/4 of the value left over. So you're never going to get down to 0. Let me just finish this video by doing one other example of a word problem. And let's say that you bought a second car and it has this equation. 15, let's say I'm going to hide the graph for a second. Let's say it's 15,000 times, let's do 4/5 raised to the x. What do those two things tell me? Well, the 15,000 tells me the starting value of the car. So this right here is its starting value. And the 4/5 means something. It means that it keeps 4/5 of the value, or equivalently, that it loses 1/5 of the value each year. Okay, so let's look at the picture. And you can see that this one actually is a little bit less steep. It costs less at the beginning, 15,000 versus 20,000, but it loses less of its value. In fact, where they cross over is the point where they would be worth the same value. And then after that, the black curve is actually worth more. We'll do one more bonus question here, just because, why not? Oh, why are you doing that to me? Okay, whatever. So one more. You might see an equation that looks like this. Y equals 12,000 times, let's do 3/5 raised to the x. And now in this example, 12,000 is still the starting value. We just need to be a little more careful with the fraction. The fraction means either you keep 3/5 of your value each year, or it means you lose 2/5 of the value each year. Okay, so please keep working on this idea. Exponential decay means you're losing a fraction of your original value, and you can figure out both the fraction that it keeps and the fraction that it loses, because those two fractions need to add up to one whole unit. Okay, let me know if anything was confusing. Happy to help out.